Okay, so we're going to graph a few functions, square root functions and cube root functions. We're going to start with this guy right here, and we're going to graph the modifications of the parent function y is the square root of x, and I'm going to start by building a t-table. So if I have the parent function y equals square root of x, I can sort of build a little t-table, and this will help me graph my function. So I have x and y. And I'm going to choose some perfect squares because it makes it easier. So when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. So those were easier ones to plug into my square root function right here. So, I'm taking the square root of 4 to get 2. I'm taking the square root of 9 to get 3. And I just purposely chose those because they're easier to graph. When I'm looking at my function, the transformations that are occurring here is I'm having a negative, which is going to make that thing upside down, and I have this -2, which is going to move the whole thing over this way too, and then I have this +3. This +3 right here is going to move this whole thing up 3. And I'm going to start by having the beginning first where I've shifted it to the right 2 spaces and up 3 spaces, and then go from there. So if I go over 2 and up 1, 2, 3, that right here is where I'm going to begin. And that handles this shift right here, these two things here. And then I'm going to deal with this. I'm going to deal with this guy right here. Okay, so I'm going to deal with that negative sign right there. So when I do that, I'm going to build a new y part of my table, and I'm going to say, well, I'm really taking -1 times y. So I change all my y values. So I'm taking -1 times 0, which is 0, -1 times 1 is -1, -1 times 2 is -2, and -1 times 3 is -3. So I'm not really using those. And I'm not really plotting where these guys are in the xy plane. I'm kind of starting from my shift, and then I'm counting from there. So I'm going to treat this as if this were 0, 0. It's not, but I'm going to treat it like it is, so that way I can count where this 1 and -1 is. So I'm going to count where it's over 1, down 1, so that's going to be here. And then I'm going to count where 4, -2 is from my beginning, so 1, 2, 3, 4, down 2, so that's my next point. And then I'm going to count from this beginning my 9, -3, so that's 4, 5, 6, 7, 8, 9, down 1, 2, 3. So that gives me my next point. So I'm going to erase all my little counting here. And then I draw in my line. So that's going to be my graph. Okay. Then I need to find my domain and range. My domain is how far over does it go in the x direction. It starts here at 2 and then it goes on forever. So I'm going to say my x's are always positive from 2. They're greater than 2. And then my range is my y's, and I'm saying my y's start here at 3, but it goes down forever. It's going to the right, but it's also going down. So it's going from 3 down forever, and I'm going to say all my y's are less than or equal to 3. And my vertex, or my beginning point, this beginning point right here, is where x is 2 and y is negative or positive 3. Okay. I'm going to do my next one. This one is a cubed root. And when I'm doing my cube root, I'm going to begin with a table for that function. So if I have y equals the cube root of x, then I want to do a table like this. So I've got this xy table. And I'm going to start with -8. And when x is -8, this is going to be -2. When x is -1, it's -1, 0, 0. When x is 1, y is 1, and 8, and 2. So that gives me some points to start with. It makes it easier because I'm taking the cubed root. Here we go. I'm taking the cubed root of x, so y equals the cubed root of x. All right, what I'm looking at here is I have this moving this way 3 and this moving this way 2. So I'm going to start with that and say, well, it would have been at 0, 0, but I'm moving it this way 3, 1, 2, 3, and then up 2. So this is my new 0, 0. That's where I'm going to start. And from there, I can count as if that's 0, 0, where my negative 8, negative 2 is, and so forth. So if this were 0, 0, then I can count from here and go, well, this would be x is negative 8 is 1, 2, 3, 4, 5, 6, 7, 8, and down 2. That's this guy right here. And from here, negative 1, 1 would be negative 1, 1. And from here would be 1, 1. And from here, that's 1, 2, 3, 4, 5, 6, 7, 8. And up 2, up 2. So I'm just counting from my new shift. And then I'm going to erase all my little counting here so it makes it easier for me to draw in my curve and say that this is going to be the graph of the line. Okay, just like that. And then I'm looking for my domain and range, and I'm saying that my x's are going this way forever and my y's are going this way forever. So this is going to give me my domain being all real numbers. And then my y's, they're going, we're going this way, but we're also going down. And we're going this way, but we're also going up. So my y's are going to be all real numbers as well. And the vertex is, how did this thing move right here? Well, it moved this way 3 and this way 2, so I'm now at negative 3 and 2, and that's my vertex.